In this lesson, we're going to take a look at solving exponential equations, which is all about using the formula a to the x power equals a to the y power. If a to the x is equal to a to the y power, and what that's saying is that if you have a base like a equal to the same base, and you've got different exponents, well, the exponents actually have to be the same. So if I was to look at a really easy or simple version of this, if I had 2 to the x equals 2 to the 9th power, what we're saying is, well, if the 2's are the same, then the exponents have to be the same, and x has to equal 9. Or another example, if I had 9 equals 3 to the x power, we would actually have to do a little more work and take the 9 and make it have the same base as the 3. So that would end up with 9 is really 3 squared, so I can write 3 squared equals 3 to the x, which means the x equals 2. So we'll see a little bit of that in all these three equations that I've actually got set up for us to work through. Okay, so let's take a look at the first one, where our base is 3 in both equations. So because the base is the same, and we've got an equal sign, that must mean that the exponents have to be equal to each other. So we actually take them and write them off to the side and say, well, x plus 5 has to be equal to 2x plus 8. And we go ahead and solve this equation by isolating x. And I can subtract this x to the other side, and that will end up with x plus 8 equals 5. And then I subtract my 8 to finish isolating the x, and I'll get x equals negative 3. So we can actually check that answer and put my negative 3 in for x in both sides, and I'll end up with 3 to the negative 3 plus 5, which is 2, equals 3 to the 2 times negative 3 plus 8, and this will give us 2 as well, because it's negative 6 plus 8, which is 3 squared, and 3 squared does in fact equal to 3 squared. So it checks out. The answer for the first one is x equals negative 3. So let's go ahead and try the second one. The second one, I got 9x equals 27. Well, this one's a little harder because neither side has the same base. And I don't know about you, but I can't make 27 turn into a 9. I know that 3 times 9 is 27, but that doesn't quite work. But actually, the 3 is a hint, because I can turn the 9 into a 3, because 9 is really 3 squared. And I'm raising that to the x power, so it's really 3 to the 2x power is the same thing as 9 to the x. And 27 I can rewrite because it's 3 cubed. 3 to the 3rd power is 27. So, again, I thought through what bases I can make them the same as, because I can't make the 27 turn into a 9. It's not like 9 to the 2nd power, because 9 squared is 81, so I already overshot it. So I have to reduce this to an even further down number. And the 9, I did the same thing. I went down, it's 3 squared. So now these both have a base of 3, and now the exponents have to be the same. So what that means is that 2x has to be equal to 3, which means, if I divide by 2, x has to be equal to 3/2. And that's my answer. Okay? If you raise 9 to the 3/2 power, you will actually get 27 on your calculator. When you do it, if you wanted to try this, just put parentheses around the 9/2. 9, so on your calculator it would look like this: 9, up arrow, parentheses, 3 over 2, and then close parentheses, and you would actually get 27. Okay, so let's go ahead and take a look at this final problem. And what we're going to do is we're going to notice that I can actually make 16 into a 4. Because again, they're not the same base right now, but I need them to be. And to do that, I need to rewrite the 16 to be 4 squared. Okay? Now it's 4 squared to the x plus 2 power. In other words, you times the exponents together, and that's equal to 4 to the 3x minus 1. Now that my bases are the same, the number at the bottom is the same, I can set the exponents equal to each other. In other words, 3x minus 1 equals 2 parentheses x plus 2. So whenever you make the base smaller, you need to take that extra new power and times it by whatever was there before. And I do that by distributing in this particular problem to make this 2x plus 4. equals 3x minus 1. And that's to isolate the variable. I subtract my 2x, and that gives me x minus 1 equals 4. And then I go ahead and add my 1 to both sides, and I get x equals 5. So now we're going to take a look at some even more complicated ones. And again, it's all about making the bases the same. So when I have something like this first problem on the left, your mind might be spinning and wondering, how in the world am I supposed to make 6 and 216 have the same base? Well, you actually need to work through what the powers of 6 are that will give you 216. And you don't have to go very far, because 6 to the third power is actually equal to 216. Okay, well, that doesn't help you out a whole lot, because now you've got 6 to the x power equals 1 over 6 to the third, because 216 is 6 to the third power. Well, I can't have it on the bottom, because that won't help me. That doesn't work with my rule. I need this base to go up to the top. Well, to go from the bottom to the top, all we have to do is make the exponent become a negative. So if I rewrite this to be 6 to the x is equal to 6 to the negative third, now I actually am very good to go. 6 to the negative third, if you type that into your calculator, you would get 216, because 6 to the third is 216, and this was on the bottom. Sorry, you won't get 216, you'll get 1 over 216, which is what I wanted here. And that's because 6 to the third is 216, and if you have it on the bottom, if you raise it to a negative third, it puts it on the bottom. So anyway, now that my bases are the same, the exponents should be set equal to each other, and what that means is that x is equal to negative 3. Okay? And if you actually take your calculator and push 6 to the negative 3, you would get 1 over 216. Now we're going to take a look at this final fraction problem, and what you'll notice is that we've got 2/3 to the x power, and then 9/4. Well, 9/4 is not 2/3, and it does not reduce to be 2/3, because nothing goes into 9 that also goes into 4. But I do know, hopefully you can see, that if I square 3, this is 3 squared, I would get 9. If I square square 2, I would get 4. Well, that still doesn't help me, because notice this is 2/3, and now I'm looking at 3 squared over 2 squared. Well, at least we're closer. We've got our 3 and our 2. So 9/4 is actually equal to 3/2 squared. Okay? And notice they both are squared, so what that means, I can pull it out and have parentheses. Now, I just need it to flip over. Well, I can flip a fraction over by putting a negative sign on the exponent. What that does is it causes the fraction to flip, and I actually get 2/3 to the negative 2 power. So now I've got the base that's the same as the 2/3 base that I started with to the x power. The exponents are then the same because the bases are the same. So x is equal to negative 2. Okay? So the goal with these problems is all about making the bases be the same, and then you set the exponents equal to each other and solve for x if you need to do any isolating after that.